Assalamualaikum warahmatullahi wabarakatuh, student. Okay, today I will give a lecture on a mechanical stabilized retaining wall. Okay, first for the introduction, okay, since 1970, okay, they already use the soil reinforcement such as the metal street, GeoTextile, Geogrid to reinforce the structure, such as the foundation, retaining wall, embankment slope. Okay, so all of the structure, retaining wall, which is stabilized or reinforced by the reinforcement material, okay, we call it mechanically stabilized retaining wall. Okay, let's go to the slide presentation. Okay, I will explain. This one. Okay. Okay, our topic is on the mechanical stabilized retaining wall, okay, which is the wall, okay, stabilized or reinforced by the reinforcement material, which is metal strip, okay, geotextile, geogrid, geocomposite, yeah, we call it mechanical stabilized retaining wall. Okay, so the benefit, okay, of the soil reinforcement is to increase the tensile strength. Okay, this one number one is to increase the tensile strength. Okay, number two is the shear resistance developed from the friction of the soil reinforced interface. Okay, so the interface between the soil and the reinforcement will develop the shear resistance. Okay. Okay, first type of the soil reinforcement is the metal strip. Okay, so it is the galvanized steel strip we normally use as a soil reinforcement. Okay, so as you know, the metal is subject to corrosion. Okay, so to design the thickness, okay, of the reinforcement strip, okay, the metal strip. So this is the equation. So TC, the actual thickness of reinforcing strip to be used in construction. Okay, so as a designer, as an engineer, so you have to design, you have to choose what is the thickness of your metal strip. So the equation is TC equal to T design. Okay, T design is the thickness of strip determined from the design calculation. So as an engineer, so you have to calculate the T design. Okay, the T. And then you have to plus with the rate of corrosion. Okay, this one usually you can get from the supplier the R. Okay, lifespan of the structure. Okay. Okay, so this is the figure of the metal strip. So the first figure, okay. So you have the yellow color is the soil, okay, and then you have the metal strip here, okay. So you have to calculate, you have to determine what is the how you want to arrange, okay, for your metal strip. So you as a designer, you have to determine how to arrange the metal strip. Okay, what is the spacing between them? Okay, so so they have few types. Okay, so you can see from the figure. Okay, so you have extendable, the first figure, so you cannot extend. Okay, the metal strip. So that is the length that produced from the factory. Okay, and then you have also the left, you have the metallic grid. Okay, so there is the figure show what the shape. Okay, and then the right one is the rib strip. Okay, so this is there are some few types of metal strip that you can choose in the market now. Okay, and then we have second one, we have biodegradable biodegradable fabric. Okay, so usually we refer to geotextile. Okay, geotextile we have a few types of geotextile. Yeah, we have woven, knitted, and non-woven. Okay, so woven geotextile made by two sets of filament or strand, okay, interlaced to form the structure. Okay, knitted geotextile interlock, okay, the filament or strip. Okay, so you can see the figure after this. Okay, so this is the woven geotextile. Okay, you can see there's a lot in the market. Okay, so this is the figure. Okay, they use a strand here. Okay, you can see. Yeah. And then non-woven geotextile formed from the filament or short fiber. Okay, non-woven is formed or made by the fiber lah. Okay, so it will combine the fiber and glued together. Okay, so there's a few process of the combination. Okay, which is a chemical bonding, glue, rubber, latex, and then thermal bonding and mechanical bonding. Okay, to form the non-woven geotextile. Okay, so this is the figure of non-woven geotextile. Okay, so if you can see here, okay, it's made by fiber lah. Okay. Okay, so this is another example of non-woven geotextile. Okay. Okay. They have four primary usage of the geotextile in foundation engineering. First is for the drainage system. So it can channel the water, okay, and also provide the high soil shear strength and the stability. Okay, and then for the second one is for the infiltration. Okay, so it can allow the water to seep through. Okay, geotextile will allow the water to seep through. Okay, and then it also protect the fine grain soil to wash being washed lah. But okay, so that is the purpose of geotextile. Okay, another reason that we are using geotextile, it can act as a separation. Okay, it can separate, help to keep various soil and layers separate after the construction or during the projected service period. Okay, so it can use as a separator, okay, of the soil. Okay, and then as of course as a reinforcement, it can increase the load bearing capacity of the soil. Okay, if you use geotextile, it can increase the load bearing capacity of the soil, meaning that the ability of the soil to carry the loads. Okay. Not only to strengthen the soil, it also can increase the soil bearing capacity lah. Okay, meaning that it's not not only the purpose not only to sustain the soil from collapse, it's also increase the load bearing capacity of the soil. Okay, so another type of soil reinforcement is the geogrid. Okay, geogrid. Okay, just now we learned about the first one is the metal street, and then geotextile, and the third one is the geogrid. Okay, geogrid are the high modular polymer material, okay, such as polypropylene and polyethylene prepared by tensile drawing lah. Okay, and then it has a few types of geogrid, which is inertial and biaxial. Okay, so inertial meaning that only one axial lah. Okay, and you have also biaxial. Okay, so so the major function is of the geogrid is act as a reinforcement lah. Okay, so and then the aperture meaning that the opening, okay, the opening in the geogrid allow the interlocking between the soil and the rock to perform a function of reinforcement. Okay, meaning that the interlocking the aperture allow the soil to interlock to each other, and then it will increase the strength of the soil. Okay, so this one inertial, example the figure A, inertial geogrid. Okay, this one is biaxial. Okay, inertial meaning that one exists only. Yeah, one exists only. One exists. Okay, and then biaxial, and then we have also rectangular aperture lah. The shape is rectangular. Okay, this one you can choose lah in the market. Yeah, and then this is the thermo welded geogrid lah. Example of thermo welded geogrid. Okay, so as I said just now, the aperture allowed the interlocking from the surrounding soil. The aperture meaning that the opening, yeah, the opening of geogrid allow the interlocking with the surrounding soil to increase the stability of the soil. Okay. Okay. I will proceed the next slide in the next session. Okay. Bye. We stop here first. I will continue the next session.